Assalamualaikum warahmatullahi wabarakatuh. We are from Group Miya and today we are going to present about Nmap Scan on operating system which is Chrome OS. But before that, let us introduce ourselves first. My name is Humaira Dayini binti Mohd Tarmidi and my metric number is 1190576.
My name is Nurul Atiqah binti Razak and my metric number is 1190560. A bit introduction about Chrome operating system. Chrome OS is a Linux-based operating system designed by Google. It is derived from free software Chromium OS and uses the Google Chrome web browser as its principal user interface. Chrome OS is only available pre-installed on hardware from Google manufacturing partner, but there are unofficial methods that allow it to be installed in other equipment. Its open source upstream Chromium OS can be compiled from downloaded source code. Early on, Google provided design goals for Chrome OS but has not otherwise released a technical description.
Next, we are going to proceed with the demonstration and packet analysis. First thing to do is to open Chrome operating system through VMware. When the virtual machine is up and running, log in to the operating system to access. Then, Chrome's command prompt crush is opened by pressing Ctrl, Alternate, and T button all at the same time. A command is inserted to view the IP address. As we can see here, this is the IP address. After that, we are going to ping the host IP address on crush. We can see that the packet is sent successfully to the host. We are going to do the same on the host command prompt. The packet is successfully sent as well.
First command is the Nmap command. This command is for performing a quick scan. The F flag will list ports on the Nmap services files. Because the fast scan flag does not scan as many ports, it isn't as throughout. After executing the command, the scan took 1.66 seconds and you can see here all the ports are open.
Second command we use is nmap npnst. PN, which is no ping option, skips the Nmap discovery stage altogether and tells Nmap to never reverse DNS resolution on the active IP addresses it finds. We are going to use these two options on every command. The ST command is for TCP Connect port scan. It should note that this scan ensures listening to the port via a three-way manual connection between the source port and the destination port. After doing this, if the port is open, the source request with the SYN packet sends the SYN response destination, the ACK packet, and then the ACK packet source. Before sending command, we are going to start packet capturing on Wireshark. As we can see, it took 2.39 seconds to scan and port 80 is filtered. At this point, you can look over the sequence of packet transfer between source and destination capture through Wireshark. Source sends SYN packet to the destination, destination sends SYN ACK to the source, and source sends ACK packet to the destination.
Third command is nmap ss. SS will do TCP Simple Scan stealthily. Sync scan is one of the most popular scan. This type of scan can be done easily and quickly and scan thousands of ports every second. It is also relatively typical and stealthy since it never completes TCP connection. Note that the port is also open if an SYN packet without ACK flag is received in response. Note that this scan is referred to as half-open scanning because you do not open the full TCP connection. After executing the command, the scan took 1.38 seconds and port 80 is also filtered. We can see at the packets on Wireshark that source sends SYN packet to the destination.
Fourth command is SF. A FIN packet is used to terminate the TCP connection between the source and destination port, typically after the data transfer is complete. In the place of an SYN packet, Nmap starts a FIN scan by using a FIN packet. If the port is open, then no response will come from the destination port when the FIN packet is sent through the source port. As in the previous steps, you can type the following Nmap command for TCP scan as well as start Wireshark on another hand to capture the SYN packet. The port is open filtered and it took 1.66 seconds to scan. You can see in the Wireshark Source send fin packets to the destination and destination send no reply to the source.
Fifth command is SU. UDP scan work by sending UDP packet to every destination port. It is a connectionless protocol. For some command ports, a protocol-specific payload is sent to increase the response rate. A service will respond with a UDP packet, proving that it is open. If no response is received after this transmission, the port is classified as open filtered. This means that the port could be open or perhaps packet filter are blocking the communication. Type following Nmap command for the TCP scan as well as start Wireshark on another hand to capture the sent packet. The port ID is open filtered and 2 seconds are taken to scan it. Look over the sequence of packet transfer between source and destination captured through Wireshark. Source send UDP packet to the destination and destination send UDP packet with some data to the source.
Sixth command is SA. This scan is different than the others discussed so far in that it never determines open or even open filtered ports. It is used to map out firewall rule sets determining whether they are stateful or not and which ports are filtered. The ACK scan probe packets has only the ACK flag set. When scanning unfiltered system, open and closed ports will both return and reset packet. Nmap then labels them as unfiltered, meaning they are reachable by the ACK packet, but whether they are open or closed is undetermined. After executing the command, you can see the port is here filtered and it took 3.6 seconds to scan. The packet on Wireshark shows that it only has ACK scan.
Last command is SN. A null scan is a series of TCP packets which hold a sequence number of zeros. Since there is no flag in this type of scan, the destination does not know how to respond to the request. For this reason, it destroys this packet and does not send any response indicating that the port is open, filtered, and the scan took 1.92 seconds. By executing the command, you will see that the port 80 is open. As you can see in the image below, source send null packet to the destination and destination send no reply to the source.
So, in conclusion, different operating systems will react differently during Nmap scan, and it is being shown on packets capture on Wireshark. Wireshark has many capabilities and you can use it to check packages sent and received on the internet for every operating system you want, so that you can use it to detect and close all possible vulnerabilities that attackers might exploit. That is all from us. Thank you.